Hi, my name is Farahani, and I'm a project geophysicist here at Seequent. In this short video, I'm going to continue explaining how to set up your VOXI time domain EM project. Once we've created our mesh, we can use the Add Wizard Data from here or here to add the data. Provide the database containing the observed data. You can browse to your database. This database should have a defined projection and assigned X and Y channels. The option is available for 2.5D time domain EM to use the active line. From the selected lines, you can just choose the active line that you would like to invert. For the terrain clearance, the vertical position provided is the terrain clearance. This is usually the radar altimeter. Here in this database, we have the height EM for the channel containing the terrain clearance of the sensor. Please consider that it's usually recommended to choose the optimized data sampling and use one sample per cell. However, in such cases like this dataset, that the data is flown at 45 degrees, you may want to choose more points per sample in the optimizing sampling mode or totally turn off the optimized sampling. Now it's time to define the model type, which is conductivity in time domain EM method, and also to find all the configurations of the survey that you are working on. You can find all this information from the survey report. And the good news is that you can save all the configurations and use it in any other inversion that you would like to do on this dataset. Now it's time to choose the channel that you would like to invert the data from. The data type is dBdt and the component is Z. I'm choosing the relative error by default and a fraction of relative error 5. Next step is to figure out what minimum error value to use. There are a few ways to figure out the minimum error value in Oasis montaj. One way to estimate the minimum error fit is to visualize your data in 2D section viewer. If you have the Geophysics extension or the EM utilities, you can use the 2D section viewer. I'm just going to show the channel that I would like to invert here. This is my data, and I'm going to show that with the data scaling of log here. I'm going to play around with this log minimum number, choose 0.01. You'll see that I can see my anomaly is really clear here. If I add one more zero here, go down to 0.001, you can see that I still have all the data here. If I add one more zero and go further down to 0.001, you can see that the data has started to become noisy. So this can be a threshold for me that the data is noisy here. So 0.001 would be a good estimate of the minimum error fit for that database. Now that I've added my data to my mesh, it's really interesting to know that by click right on data locations, you have this option to navigate to another line if you would like to invert another line. Next step is to add the windows and waveform. You can click right to add and modify your waveform. We're importing our waveform from a database. We have the database. We have the time channels saved in time. Channel to upload is TX, and we have the TX current. So next exercise is to click on this calculator. Everything was referenced to 0. So obviously we need to shift the time channels relative to the end of the transmitter pulse. It's time derivative of the transmitter current that you see in red. Once it reaches to the half maximum value of di over dt in turn of time, it's gonna be considered the shut-off time. So now your time windows have been shifted relative to the end of the transmitter. Once we add our waveform, we are technically ready to perform any inversion or forward model. And thank you so much for watching.